But so yeah, you will not need to know uh, like first order conditions, like profit maximizing with unconstrained quantity. That's something that we'll cover next week. Um, as for what you will need to know, so expected utility, conceptual stuff about insurance, definitely. Elasticity, I think, is probably going to be a big one. There was actually a really good elasticity problem that I did in my drop-in yesterday. Um, it was in your preparation for midterm three. So that's a really good elasticity problem. There was tax incidents like dead weight loss and all that, and market demand. And then for this last block of material, it is like returns to scale and cost minimization. So I don't think so. Cost curves are kind of in the um, ballpark of profit maximization. I don't believe you'll be required to know that. Um, I think that basically anything past cost minimization, you don't really need to know. I mean, obviously you would want to know it, but it's not going to be uh, tested on your midterm. So, with that being said, I figured we would probably just go through a good amount of problems, try to get as many done as possible. And I'll try to cover every sort of segment that I've just mentioned. Like, we'll do some expected utility, we'll do, let's see, we'll do cost minimization, we'll do all that stuff. Um, are there any specific problems that you guys would want me to address? Otherwise, I'm just going to kind of go through the Gaucho space and handpick problems from there. All right. So it looks like no one has a specific problem, and so that's all right. I don't mind just going through problems. So let us see one problem. I'm going to do a combination of like midterm twos and final exams, just because there is an overlap in the kind of questions you'll be needed to know. So here is a question from midterm two of fall 2018. And the question is, in insurance, uh, what must be true if someone fully insures? And so the answer choices are A, CG must be greater, or consumption in the bad state. Whoops. So CB is greater than CG. Answer choice B is utility is maxed for risk loving. And part C, so dollars of insurance is less than amount of loss. And answer choice D is, answer choice D is probability of the bad state is less than 1/2, and answer choice E is none of the above. So I'm going to give you guys probably like a minute or so to kind of just think through this and leave your answer choices in the kind of chat. I want to see what you guys think, and if you guys could maybe provide justification for why you think the answer is true, that would be even better. Because I would love to hear your guys' thoughts on this. And in the meantime, I'm going to look for more problems. All right. I'm seeing a lot of E's. Does anybody who selected E want to justify why you guys chose that? Maybe just a quick explanation. Um, Otherwise, I don't mind doing that. All right. I guess I will just kind of explain why the answer choice is E. So that's correct. I want you guys to kind of think through each of these answer choices and kind of think about why it's false, right? So let's see. Connor kind of explains. So with answer choice A, we know that when someone fully insures, that's because consumption in the bad state must equal consumption in the good state, right? We know that our consumption in the bad state is M minus gamma, whatever the, so that's not a gamma, M minus gamma L, right? M minus gamma L, and consumption in the bad, or consumption in the good state is also M minus gamma L. So we know that these two are equal to each other, and we kind of showed that in the lecture, right? That I talked about expected utility and insurance. But yeah, we know that these two are actually going to be equal. And so let's look at answer choice B. Right, so this is wrong. Answer choice B says that utility would be maximized for someone who is risk loving. We know that that's not true. We know that if someone fully insures, then that kind of tells us that they are risk averse, right? Someone who is risk loving would choose to have no insurance. Okay. And so let's look at answer choice C. Dollars of insurance is less than the amount of the loss. Well, dollars of insurance is uh, basically going to be K, right? So the amount of coverage, right? So this is, you can think of dollars of insurance as being K and the amount of loss as being L. When someone is fully insured, K is equal to L. And so this inequality cannot be true, right? It should be that they're equal to each other, okay? And probability has nothing to do with whether someone fully insures or not. Um, that has more so to do with like fair insurance, if anything. And so we know that fair insurance is only when the probability is equal to one another. So um, this this is not true. I mean, it could be true, but it's not like it's always true, right? So that's why the answer is E, none of the above. And so I definitely recommend you guys kind of, as you're approaching these problems, think through why each of these problems or why each of these answers could be wrong. Like create an argument, and then that'll definitely lead to you guys kind of coming up with better thought out answers. So yeah, E, none of the above. Uh, in the same midterm, there's problem 5, and this is a market demand problem. And so we're going to kind of cover this and see how we can approach this problem. So we're given that D of P is equal to 200 minus 2P. And we're asked, what is consumer surplus if P is equal to 60? Okay. I think definitely the best way of approaching this problem is just to kind of graph it out. So we have P on this axis and we have D of P. And just remember that your demand is a function of price, right? Usually we're used to the y-axis being a function of the x-axis, but it's switched. So that's just something to keep in mind. Definitely, I think that finding your axis points is probably the best way of graphing. So we want to find what this axis is, right? So we set d of p equal to 0, right? And we're able to get that p is equal to 100. So essentially, when the price is 100, nobody is going to be demanding anything, right? So what happens when the price is 0? Well, then demand is just going to be equal to 200. right? And so we have this slope that looks kind of like this, right? Where a slope is -1/2, okay? And we're asked what consumer surplus is when the price is 60. So you want to find this area right here. This is our consumer surplus, right? Because it's the area that's underneath the demand curve, but above the price, right? So it's going to be some sort of triangular area, okay? Now, this is a fairly easy problem, but just graphing it is probably going to be the hardest aspect of this problem. Also, making sure that you're multiplying by the right stuff, right? So we want to see what D of P is when P is 60, right? So D of P is equal to 200 minus 120, right? And so this is equal to 80, right? So this person is consuming 80 units when the price is 60, okay? And so the way that we find out this area is just 80 times 60 over 2, right? Remember, you have to divide by 2. That's kind of, it's trivial, but people forget. And so it's just good to always remember that. And so this is 4,800 over 2, which is equal to 2,400, right? And so that is the, wait, hold on. Actually, I want to double check that. Oh, okay. So that's actually a really good catch. I want to make sure that you guys don't make this mistake that I just did, right? Where I multiplied 80 by 60, but what I really should have been multiplying it by was 80 by 100 minus 60, right? So 80 times 100 minus 60 over 2 is what my answer should be, okay? So I'm lucky that I cut that myself, but it's something that could easily kind of pass like over your head as it just did to me. And so this is 80 times, let's see, 40 over 2. This is 3,200, so this is 1,600. And so you guys can clearly see that the answer is not one of the answer choices, whether you have it up or not. Just the fact that you got the right answer is what kind of is important. Yeah, Becky, you're right. Okay, and the last problem that I want to take you through on this midterm is problem 6. So hopefully this is everybody's comfortable with this. The last problem that I want to kind of go through with you guys is problem 6, and it gives us not really a ton of information. We're given that utility at $100 is equal to 500. The utility at 200 is equal to 580, and that the utility at 300 is equal to 700. And we're asked, what type of consumer is this, right? Is this person risk averse? Are they risk neutral, or are they risk loving? And how do you go about finding this information? So this is fall 2018 again, midterm 2. So if you want to just follow along. But this is kind of the information that is presented in the problem, if you want to just follow along on the board. But what do you guys think? What kind of individual is this, and why? All right. So I have someone saying risk loving. I have another person saying risk loving. and I have a few people saying risk loving. All right. Um, so let's see why people are saying risk loving. Okay. And I think that the best way to do this is to graph it out, and you'll get a better kind of idea, right, of why. So we have dollars right here on the axis, right? So this is going to be like wealth, right? And this is your utility from wealth, okay? We have that $100 of wealth produce 500 utility, okay? And I want to make sure that I graph this pretty accurately to scale, right? We got that $200 of wealth produced 580, right? So we have something that looks like this. And we have that 300 of wealth produced 700, okay? And so if you kind of track the movement of this, it's pretty subtle, but you should notice that this kind of forms a parabola, right? And so we know that based off of either my lectures or the lectures that you guys go to, that this is kind of the typical shape of someone who is risk loving, right? Because you can see that their marginal increase is, or I guess their marginal utility from an extra dollar is increasing, okay? Um, Someone who would be risk averse would have something that's shaped like this, and someone who is risk neutral would have something that is just kind of a straight line, all right? So that's definitely something that you guys are going to want to just be aware of when you're approaching these problems. But yeah, you guys did a really good job with that. Okay. So let's move on to some other problems. I want to take you guys through, let's see, let's do extra problem set 7. This kind of has to do with production. So extra problem set 7, let us do question 2 first, right? Question 1 is pretty straightforward. So question 2, we have that the I guess input bundle 9.1 produces more output than 1.9, right? And so we have to find out a production function that matches that. So the answer choices are A, L, K to the 1/2. There's B, L to the 1/2, K. There's C, L, K. And then there's D, L to the 1/2 plus K. And then there's E, none of the above. And actually, I don't know the answer to this quite yet, but I want to hear what you guys kind of have to say about this. I don't believe you'll see marginal cost or average cost. I mean, the average cost is basically just the total cost divided by the quantity. And marginal cost is basically your total cost and like the derivative of your total cost with respect to quantity. So, I mean, I can kind of just briefly talk about it real quickly. I don't think you'll see it. But yeah. So this question at hand is basically saying which production makes it so that the input bundle 9.1 produces more than the input bundle 1.9. Okay. I'm seeing some answer choice A's, right? And so let's kind of talk about that. So I think the best way of just going about this kind of problem is just to plug in the numbers, right? And just seeing which produces this outcome. So if I plug in 9.1, I should get 9 times 1 to the 1/2 is equal to 9. versus 1 times 9 to the 1/2, which is equal to 3. And so this makes sense. And I think that in most cases, you can probably just leave it and not even worry about any answer choice like B or C, um, or like B, C, D, or E. But it doesn't hurt if you have time to just kind of go through each of these answers, and you might find that you solved part A wrong and that you actually figured out like part D was correct, for example. And so um, that's just kind of my advice to you guys when going through the midterm. But I know that there is a time crunch, so I think definitely you can feel pretty confident, especially if it's an easier problem like this. But I do want to kind of let you guys know that I have in the past realized that one of the answer choices that I forgot about was right. Um, so yeah, it's kind of whatever you guys feel comfortable with. Let's pick another question from this lot. Which of the following? So, okay. So this is actually something that I'm not sure if you guys are going to need to know, but I will cover it just in case. And it has to do with like average production of labor. So let's kind of look at this. So this is question 6. This is question 6 on the same extra problem set. And we're given that FLK is equal to, so the square, this is the cube root of 18L plus 9K. And we're asking, is average production of labor at the 0.88 greater, or average production of capital at the 0.88 greater? So how do we go about this, right? Well, average production of labor is actually not very complicated. So it kind of sounds complicated just because they give you this notation and they don't really explain what they mean. But average production of labor is basically just going to be your quantity over your labor, right? And so this is pretty much all it means is how much does each unit of labor contribute to quantity on average. And so this is kind of the equation. They might not always give you a specified point. And so when they don't give you a specified point, they pretty much just want you to put this whole production function over labor, right? And so maybe this doesn't work so well for something like this, but say that we had 8L to the 1/2 over K squared, for example. This was our production function. Then the way that we would find the average production of labor is to just divide everything by L, and that would kind of be it. And then you would, from there, plug in various input quantities. And it kind of works like a demand function, if you will, right? Where if you have your production function and you divide it by labor, no matter what the input quantities are, you can always find the average production of labor, right? And the same holds true for capital, right? Where you would basically just divide your total quantity by capital, right? And this is what you would get, right? In this case, because they do give us a like input quantity combination, right? You can think of it as your like bundle. They're going to be expecting a number in your answer choice. So that's kind of what is going on there. So in this case, I have my calculator, and so I'm going to just do it from there. But yeah, so 18 times 8, so the cube root of 18 times 8 plus 9 times 8 or so over L, or so yeah, hold on. Okay, and so because we know that, so this is labor and this is capital, because we know that the inputs are the same, right? Meaning that there's 8 units of this and there's 8 units of that, right? Our equations are actually going to look basically the same, right? So you don't even need to multiply it out, right? Because we know that this is FLK, right? So this is the same as FLK over L, and this is the same as FLK over K, right? So hopefully you guys kind of see that. Are there any questions about that? Right. I know that this is kind of a sneak peek into maybe material that I don't think you'll need to know for the midterm, right? I think that this is like looking forward, but it kind of does give you an introduction just in case they like sneak it in, right? Better to be over prepared than under prepared. So that's kind of what I would do with that. I'm trying to find a problem that has to deal with like returns to scale, and I'm not able to find anything. So here, hold on. Yeah, the extra problem sets are a little bit dry. So I'm going to go to some old exams. Yeah, I'll go through the practice midterm 3s. I'll see what is up with that. Okay, I'm going to do midterm 3, winter 2015. And we'll kind of work through these kind of problems. And actually, this was probably a better way of going through the problems. I've really never checked the midterm 3s because when I took the class, there was no midterm 3. So, but yeah, so this is midterm 3, winter 2015. Okay, and we're just going to go through it one by one. So this is an expected utility question. So Roberts, well, you guys can read the problem on your own, but basically his utility is equal to the square root of wealth. And we want to say, what is his maximum willingness to insure, right? Fully, I'm assuming. Okay. So we want to see what his expected utility is with no insurance. And then we want to set that equal to the expected utility of no insurance or with full insurance. So expected utility, God, I can't spell right now. So his expected utility with no insurance, right, is just equal to, so let me just kind of write down all the information. The probability of the bad state is 75%. And I guess that means that the probability of the good state is 25%. And his L would be equal to 48. So he wouldn't lose all of his money, but he would lose a significant portion of his money, right? And so how we figure this out, right, is we say probability in the bad state times utility in the bad state of wealth plus probability of the good state times the utility in the good state of wealth, right? And when you set this equation up, you get 0.75. And so in the bad state, we know that his outcome, right, is where he loses $48. So his wealth in the bad state is equal to 64 minus 48. And so this is equal to 16, right? But we know that he derives utility not from, okay, well, he derives utility in terms of the square root of how much wealth he has, right? So each dollar of wealth produces him a square root, right, of whatever amount he has. So that's why when we find the expected utility, we have to include the function of his utility in that kind of equation that we've set up, right? So this would be times the square root of 16, okay? Because this is how much he values $16, and this is the probability of that event happening is where he has $16, okay? And so the good state is 0.25 times the square root of 64, right? In the good state, he doesn't lose anything when he has no insurance. So when we figure out what this value is, right? So this is 1/4 times 8, and this is 3/4 times 4. So this is equal to 2, and this is equal to 3, okay? So his expected utility when he has no insurance is equal to 5. And we want to match this up against his expected utility with full insurance. So expected utility with full insurance, right? And so the probabilities are still going to be the same. So let me just erase this. The probabilities are still going to be the same, where he has a 0.75 chance of getting in an accident, right? And so we need to calculate what his wealth would be in this state, right? And so we know that consumption in the bad state with full insurance is M minus gamma L, and that consumption in the good state is also M minus gamma L. And what we're looking for, right, how much he's willing to pay is gamma L, right? This is how much he pays for insurance. This is like his insurance premium, okay? So, okay, I'll look at one of those for you guys after. So I'll do fall 2014 after this question, okay? So let's go back to the problem. So what we're really looking for is gamma L, okay? And so we know that M is 64. So 64 minus gamma L, right? Plus 0.25. And so this is the probability of not getting in an accident. So this is the probability of like the good state occurring. But we know that in the good state, his consumption is also M minus gamma L, okay? And what you noticed, so M is 64, so we'll just kind of plug that in for now. What you'll notice is, God damn it, this is like that. And so what you'll notice is that these two terms add up to 1. And so this simplifies out to 64 minus gamma L, right? And so we need to find out what gamma L is. And the way we do that is we set our expected utility with no insurance equal to our expected utility with full insurance. And so we set this equal to 5, right? Because this is kind of like the equilibrium where they're like indifference between fully insuring and having no insurance, right? So this is kind of what's going on here. So to find gamma L, we just take this, the square of both sides. And so we get 25 is equal to 64 minus gamma L. And so gamma L is equal to 64 minus 25, which is equal to 39, right? So this is how much this person is willing to fully insure, right? And I want you guys to kind of think about what happens if gamma L is more than 39, right? So say that gamma L is 40, for example, right? So the cost of insuring goes from 39 to 40. How does this affect his expected utility, right? Well, if you want to do this with a calculator, I can definitely show you guys that if gamma L is 40, then the expected utility is going to be less than 5. And so in kind of contrast to that, if gamma L, right, how much he pays for insurance is less than 39, then I can assure you guys that his expected utility is going to be greater than 5, right? So gamma L being equal to 39 is where these two are exactly the same, right? So it's like the equilibrium point, okay? Did that make sense to you guys? I know that this is like, it feels like it's been so long ago that we did this, but this will be on your midterm. So yes, exactly, Victor. That's true. So I'm going to do midterm 3, fall 2014, and number 3, and kind of show you guys how to go about that. So midterm 20, fall 2014, and question 3. So if you guys want to hop over to that. So there's 2 different ways of doing this, and I'm going to show you guys both ways. So, so this is midterm 3, fall 2014, and this is question 3, and we're asked FLK equals L to the 1/4, K to the 2/3, right? And what returns to scale? Okay, so there's like the very easy shortcut that doesn't really require any sort of math. It just requires memorization. So generally speaking, with a Cobb-Douglas production function, right? With a Cobb-Douglas production function, if C plus D is greater than 1, we have increasing, right? If it's equal to 1, we have constant, right? And if we have less than 1, we have decreasing, okay? And so this is only true for Cobb-Douglas, which is why I don't want you guys to kind of bank on this. I want you guys to be able to do it for any sort of problem. So we do have Cobb-Douglas, which is why this works, but I'm going to show you how to do it more generally after this. So if you guys apply this method, I think it's really easy to see that what we're going to have is decreasing returns to scale because the exponents don't add up to 1. They add up to less than 1, right? So there's going to be decreasing returns to scale here. Now, the more general method, which I think is worth knowing because it applies to any sort of production function. So it applies to perfect substitutes, probably min. I don't know how I would apply it to a min, but like quasi-linear, for example, it would apply to that. And the way that we do this is we see how multiplying all of our inputs by some constant, right? How that compares to if we just multiply our production function by that constant, right? So I'll kind of show you guys what I mean by that. So the way that we do this, right, is we attach a constant t to each of our inputs, right? And we compare this versus t to the L 1/4, k 2/3, right? And so clearly t here has just an exponent of 1, okay? And so we want to see whether this is greater than this, whether it's equal to this, or whether it's less than this. And so it's really easy. This is like scalar invariance, just with a different application. So we know that this kind of simplifies out to t to the 1/4, L to the 1/4. And this simplifies out to t to the 2/3, k to the 2/3. And so if I were to group my t's, I get t to the, let's see, this is 3/12, this is 8/12. So this is t to the 11/12 times L to the 1/4, k to the 2/3. And you can see that we have our original production function right over here, right? This is what we have right here. And so we're making a comparison between this whole thing and this whole thing. Well, obviously, t to the power of 1 is greater than t to the power of 11 over 12, right? Which means that this is less than this, which means that we have decreasing returns to scale. So that's just like a more general way of doing it. Oh, okay. Are you asking about this, Sam? Why there's no t right here? Yeah, so t in this situation is multiplying the entire production function. So we multiply it kind of as a whole. So the t wasn't attached to the L or anything. We just multiplied it like in general, okay? So yeah, that's a good question. Okay. So there's a return to scale problem on midterm 3, summer 2015, number 4. I'm gonna go ahead and do that. Summer 2015? Yeah, I guess it's the only summer one here. And it's question 4. Okay. So let's kind of pivot to this new question. And so this is, as was mentioned before, this is a bit of a different production function. So we can apply, so just for context, L squared plus K. And what is true for all positive values of L and K? Well, we know that we can't apply, right, our usual method of do the exponents add up to 1 because we don't have Cobb-Douglas. So we're going to have to test out the kind of method that we had before. So this is like the more general way of doing it. So we want to multiply each of our inputs by some constant t, right? I think that thinking of t as being 2, where we're basically doubling our inputs, right? We want to see, does doubling our inputs result in doubling our production, or does it more than double, or does it less than double? So that's kind of the intuition between returns to scale, right? So if I do this and I apply this t constant to my inputs, what I get is t squared L squared plus tk. And so let's see, how do I pull this? So this is equal to, actually, I don't think it's worth pulling out, but just know that you could kind of simplify this a bit more. What you want to compare it to is whether I just multiply it by t, right? So t times f lk, this is equal to t times L squared plus k, which is equal to t L squared plus tk, right? And right off the bat, we know that since t, right, is just a general constant, that I guess for any positive values of t is kind of the thinking, right? Returns to scale should be where the constant is greater than 1 in order to kind of get an actual representation of what the scaling would look like. But you can see that for any t greater than 1, that t squared L squared plus tk is greater than t L squared plus tk, right? And so you guys can kind of just plug in the number 2, for example, and see that this is true. or just any constant that's greater than 1, but I think 2 works the best. So yes, so we can do this for any kind of problem aside from Cobb-Douglas. That's exactly right. Let's see. Let us see kind of which to do next. I know that we're running a little bit short on time, but I don't mind kind of going a bit over. I know that you guys have your midterm tomorrow, so I want you guys to be as prepared as possible. So we're just going to go over more of these midterm 3 questions, and we'll see whether there's any that I really like. Okay, so here is, actually, this is a pretty good one. This is from the same midterm. So this is summer 2015. This is midterm 3. And this is question number 2, right? And as always, you guys are more than welcome to leave if you guys need to. But I'm probably going to be doing this until 2, and then I have to transition to my drop-in. Fall. I'll do fall 2014 right after this one. Okay, Ryan? So this is actually a pretty good one, and this one takes into account a fixed number of capital. So I'm going to show you, just because I did cost minimization with unconstrained input, but I want to show you guys that when you have a fixed level of input, it's actually even easier to figure this out. So we have FL of K, so this is the production function taking in inputs L and K, is equal to the square root of L plus the square root of K, okay? And so we want to see how to cost min if y is equal to 3, right? And so y and q are pretty interchangeable. FLK also means the same thing, so that's kind of what the variables mean. But basically, we want to be able to produce 3 units of production, and we're given that K is fixed at $4 or 4 units, and W is fixed at 6, and R is 10, right? And so this is the cost of labor, and this is the cost of capital. So I just want to show you guys that this is even easier than if we like didn't have L and K fixed, because pretty much we can set this equal to 3, and we have the square root of labor plus the square root of 4, right? Because this is stuck at 4. And so this just becomes 1 equals the square root of labor. And so obviously that must mean that labor is equal to 1, right? And so if we know that cost is equal to, cost is equal to WL plus RK, right? This is 6 times 1 plus 4 times, or 10 times 4, I guess. 10 times 4. This is just equal to 46, okay? And so this, just to kind of reiterate, it becomes a lot easier when we have a fixed level of capital because there's no MRS that we need to kind of find, nothing like that. So let's actually see how we would do this if we weren't given that K bar is equal to 4. So let's just do the same exact problem, except we don't have fixed capital. So W is equal to 6 and R is equal to 10. I want to see if I have an MRS that has DMRS, but I have a feeling I won't. So marginal utility of labor over marginal utility of capital. This is going to be equal to 1/2 L to the negative 1/2. over 1/2 k to the negative 1/2. And so actually we might. So this is just going to be equal to square root of k over the square root of labor. And so we do actually have DMRS. So as L increases or as K decreases, we have, or this technically this is the TRS. Okay. But we do have DTRS, which means that we can set this equal to W over R, right? Which is equal to 6 over 10, right? And we can kind of solve it from there. So we get 6 times the square root of L is equal to 10 times the square root of K. And let's just solve for L for now. So L is going to be equal to 10 over 6 times the square root of K, all that squared. So this is equal to 100 K over 36. And so you can pretty much just plug this into your values of L and get that 3 is equal to the square root of basically this whole thing. So 100 K over 36 plus the square root of K, right? And then from here, you can find your cost minimizing level of capital. So if you want to kind of work through this, this would just be 10 times the square root of K over 6 plus the square root of K. This is equal to 6 square root of K over 6 equals 16 square root of K over 6. And this is all equal to 3. And so 18 is equal to 16 times the square root of K. And so square root of K is equal to 18 over 16. And so K is equal to pretty much this whole thing squared. And so obviously these numbers aren't very pretty. This question wasn't designed for something with unconstrained level of inputs. But I'm just kind of doing this work to show you that it is possible, right? And that this would be kind of the method of going about it. And so how do we, or when we do not need to find?
Real quick. And so then we found K star right there, right? And then from there.
What's up?
To find L star, we just plug in that K that we just found.
So you can,
L, right?
You can basically either do the same thing except solve for K and then go through the same process, or you can plug this value of K into here and set it equal to 3. And so that basically leaves you with one variable left to find. Does that make sense? All right.
Yeah, but to quickly find L star, we already have it in terms of K. We found K star. We just plug it into that square root K right there.
Oh yeah, you could also just plug it into here. Yeah. That's fine. Yeah, that works also. So it would probably be like, let's see, 30 over 16 squared, just off of quick calculations. But yeah, this is, you'll probably get better numbers. I wouldn't imagine you guys working with fractions like this, but that's kind of how you find it. And I'm gonna do fall 2014 number 5 just real quickly. I know that I'm like 7 minutes over. This is more so just if you guys want to soak it in. I know that the previous midterm scores haven't been great, so I kind of just want to make sure that you guys do as well as possible on this one. So this is fall 2014, question number 5.
And then you have drop-in hours after this, right?
Yeah, I do. So we'll do this question, and then that'll probably be it. And then I'll just move over to my drop-in. If you guys have any questions there, you guys are more than welcome. So FLK, and just for reference, this is fall 2014 midterm 3. So this is FLK is equal to L to the 1/2, K to the 1/2. R is 1, W is 5, and the price of the good, P is equal to 2. Oh, okay. So this is a first order condition. I don't think you guys are going to need to know this, but I'll just do it real quick, just because, I don't know, you guys might want to know it. So, and then I'll kind of explain it. So we have that K bar is fixed at 100, right? And so we're looking for the profit maximizing amount of labor. And so if you guys kind of remember the profit equation that we were working with in the past, P times FLK, right? This is our revenue. This is our revenue minus WL minus RK, right? Or I guess if you want to write it like this is equal to our cost. And so we're looking for the profit maximizing level of profit given that capital is fixed. And so I'm just going to kind of let you guys know right away, the fact that capital is fixed doesn't really matter because, and I'll just show you why in just a bit. So we want to find the profit maximizing amount of labor, which means that we have to find, or actually I'll do it in this line right here. We have to find the derivative of profit with respect to labor and set it equal to 0, right? Because this will tell us basically how we maximize our profits in terms of labor, right? And so this is equal to 0. And so you'll see that this kind of affects various portions of this profit equation. So we have it that FLK is our, this is our production function. And so this contains the variable L, which is why we need to take the derivative of this. This contains the variable L, but this does not. So we treat this as a constant, okay? So this is P times the derivative of FLK with respect to L, and then minus W, right? L is just reduced down to 1, and then that's it, right? So we have, this is the marginal product of labor, just by the way, guys. So we have that W is equal to P times MPL. And so this is like the first order conditions that you guys have seen so far in class. And so given that this is kind of what we have so far, we know that MPL, so let's kind of take this and let's solve it out. So we have that this L to the 1/2 times 100 to the 1/2. This is where you would plug it in, right? And so this is kind of how we're going to treat this is this becomes 10 to the L, 10L to the 1/2, right? And so if I want to substitute this in, I'll just go ahead and do that right now. 10L to the 1/2. Actually, no, this is not quite. So this doesn't lead to this. This leads to this, right? So this is my production function, right? And so I want to take the derivative of this, right? So this leads to 5L to the negative 1/2, which is equal to 5 over the square root of L, right? So this is equal to 5 times the square root of L. This is the marginal product of labor, okay? And so I can just plug in some of my variables. I get 5 is equal to 2 times 5 over the square root of L, right? So basically square root of L is equal to 2 after some like working arounds. And so L is equal to 4. And so that's how you would solve a problem like that. As I mentioned before, I don't think that this will be on your midterm, but you guys can kind of now see that it's a really easy process. And yeah, and I'm probably going to go over this again next week, just as a full recap. Also, because I need material to fill. But yeah, so that's how you figure it out. So hopefully you guys are good on that. I do have to run over to my drop-in hours. You guys are more than welcome to kind of come through there and ask any question that you want or have. But if not, I wish you guys best of luck on your midterm tomorrow. I hope that this review session, if you want to call it that, was useful, and that you guys all do as best you guys can on your midterm tomorrow. So there's a different link for the drop-in. I believe that it's on, actually, I have no idea how you guys even got this link in the first place for my lectures. But I believe when you signed up for CLAS, you had the option to kind of add this to your calendar. So there's probably a recurring link. Also, I have a, there's like an Econ 10A CLAS Gaucho Space page where the link is there as well. And I can maybe see if I can copy and paste that. All right, so yeah, so if you want to join my drop-in, I think you guys can probably use that link and you'll be good. So I'll see you guys there. And yeah, all right.
Bye, you're jumping into grouping now? Drop-ins?
Yeah.
The other link? Okay, I'll jump into that. Thanks.